Hello everyone, I'm Giovanni Franzese, I'm a PhD candidate at TU Delft, and today I'm going to present you some of the features and results of my work learning interactively to resolve ambiguity in reference frame selection. The general framework of application of this paper is learning from demonstration, that in the past year has shown to be an easy and simple way for learning complex policies from not expert users. With this technique, the user can show the trajectory to the robot using, for example, kinesthetic teaching or teleoperation, demonstrating how to perform the desired task. There are many applications of imitation learning where the robot is simply cloning the trajectory with respect to its global coordinate and is repeating the trajectory according to that. However, in the learning complex trajectories with a multitude of objects that are tracked in the environment, it can happen that the user intention in the demonstration of the task is not referring to the general coordinates of the robot, but with respect to the coordinate of the object that, for example, she would like to manipulate. In the video next to me, I'm in the first segment referring to the banana, and then on the banana crate, never to the general coordinate of the robot. Learning this intention will allow to the generalization of the task to the new position of the object. However, inferring the correct reference frame for each segment is not trivial and requires a set of informative enough demonstrations that the policy is using for avoiding any possible ambiguity. In fact, an ambiguous situation is defined by the possibility of having different possible generalization of the demonstrated task in a different use scenario. For example, let's analyze the scenario of the peak of a cup on a coaster when their frames are overlapping. If we don't develop a system that is aware of the ambiguities, as LIRA, the learning method could simply and arbitrarily decide the dependence respect to one of the two frames, because neither using the distance respect to the frame or using the goal variance of multiple different demonstrations will prioritize one frame on the other. So LIRA will deal with this type of situation where the learning agent cannot infer the right feature, in this case the desired reference frame, from the set of provided demonstrations. However, this version of LIRA is not dealing with other types of ambiguities, for example, the one due to multiple modal demonstration provided in the same scenario. LIRA requires only one full kinesthetic demonstration where the desired end effector position are recorded with respect to all the perceived reference frames. In a new situation with the reference frame not in the same position of the demonstration and with the relative goals that are not overlapping anymore, it can actively query the user for giving feedback about the correctness of its attempt to solve the ambiguity. For reducing the search space of the total valid candidates, LIRA also allows the filtering of them using some priors for the sake of having a faster disambiguation, without many user corrections. Different valid scenarios are investigated in this work, where also different modalities for giving feedback are implemented, in particular using a desktop interface, a directional feedback, or a local demonstration of the desired behavior. In this example, in the first row you can see the reproduction of the demonstration where the robot is picking the cucumber and then placing it in the right crate. As you can see from the picture, there are different reference frames, one for each crate and one for each fruit on the table. Because we are implementing a manipulation prior that is actually giving a priority to the frame that is going to be manipulated in the next segment, in the picking operation 2.a there is not going to be any ambiguity. In the placing operation, there is an ambiguity with multiple possible goal solutions, but thanks to the directional human feedback, this ambiguity is solved. Finally, we conducted a user study with regard to prove that the interactive way of solving the ambiguities with LIRA is less demanding on the demonstrator, compared with a not interactive and not ambiguity-aware system. The task that was performed by 12 participants was about pick and place of different boxes, as you can see in the video. When the task was performed with only kinesthetic teaching and the demonstration were not informative enough for unique selection of the frame, the robot was attempting wrong solution in unseen scenarios, and a new demonstration was then required. With LIRA, simply pushing the robot in the right direction was enough for solving the ambiguity. The NASA Load-INZ questionnaire shows a clear beneficial effect on using LIRA compared to the sequence of kinesthetic demonstration. Drawing some conclusion, we show how to make a robot aware of possible ambiguity in the demonstration, and we show how to reduce these ambiguities using priors and also the interactive correction of the user. Future works will focus on the solution of ambiguities in the selection of the right control modality, on the redundancy control of a manipulator, in the sensor fusion and multimodal demonstrations. Thanks for your attention.